Acid-base reactions between concentrated acids and concentrated bases generate a lot of heat very quickly. There can even be sparks. In this case, there's a lot of smoke. Check it out. It's really cool to watch. It'll give you some context for what we're doing here. And in this question, basically, what we're doing is we have a 500 milliliter beaker with 3.0 mole per liter concentrated sulfuric acid, or H2SO4, which is right here. And then we add a 36.5 gram chunk of solid sodium hydroxide, or NaOH, to the sulfuric acid. Obviously, you experience something similar to what you saw in that video. There's a lot of bubbling and a lot of smoke. But the two products of an acid-base reaction are always the same. A salt that's made up of the cation portion of the base and the anion portion of the acid, so sodium sulfate, and then the other product is water, because the hydrogens, which make an acid, as well as the hydroxides, which make a base, combine into water, and it should neutralize your solution. But in this case, our solution is not going to be neutralized because one of the two reactants is going to be a limiting reagent. So there's going to be either some leftover acid leaving your solution acidic, or there's going to be some leftover base leaving your solution basic. It's very unlikely that there would be an exact ratio of both of them. But we are going to move on to solution chemistry in the next unit. So I thought this was a good opportunity to introduce the idea of concentration, or basically how many moles of the acid or base is dissolved into what volume of water. And in this case, we have 3.0 moles per liter. Now, you should understand that 3 mole per liter sulfuric acid is so acidic that its pH is below 0. So it actually has a negative pH, and pH can actually dip into the negatives if acids become very, very, very concentrated. We have some of this stuff in the lab at school. It's in a scary looking plastic fridge thing that says danger acids, bases, and stuff like that. And usually you don't use concentrated sulfuric acid for reactions of acids and bases. Generally, you use concentrated sulfuric acid to make less concentrated sulfuric acid. So I would take a little bit of this and add water, and that would create a far less acidic mixture. And again, we're going to look all that in the next unit when we embark on solutions. So the first thing I'm going to do is put all the molar masses and quantities that I know about all the products and reactants here down using my magic chemistry pencil. Voila, there are all of the quantities that we know and the molar masses that we have. Now, you'll notice I did a couple things. First off, underneath sulfuric acid, you'll notice I've done a couple things here. First, I've written the 500 milliliters as liters. The reason I've done that is because concentration is moles per liter, not moles per milliliter. So it's a pretty easy switch. 500 milliliters is half a liter with 3 zeros. So I can just change that into 0.5 thousand liters, which is the same as half a liter. The molar mass of sodium sulfate is actually not going to matter in this question because we're going to determine the limiting reagent here, and the question asks us to calculate how many grams of water are produced. So where are we going to start with this? Well, the first thing I need to do is I have to figure out what the limiting reagent is, because I don't know if I'm going to use moles of this or moles of that as my starting point, because I don't know which one is going to get used up first. So I'm just going to randomly choose, I don't know, let's do sodium hydroxide here, okay? So I'm going to determine how many moles of sodium hydroxide I have, and then how many moles of sodium hydroxide I need. So let's start by finding how many moles of sodium hydroxide I have in actuality. All right, so that's 36.5 grams of sodium hydroxide. And then we're going to multiply that by 1 mole over the molar mass. All right, so that's 36.5 divided by 39.99715. And that'll give me 0.912 moles of sodium hydroxide actual. So I'm going to put a little A beside that. Okay. So the next thing I want to do is find out how many moles of sodium hydroxide I need. All right, so how many moles of sodium hydroxide do I need? Well, in this case, we're going to start with the sulfuric acid. And the quantity I've given in sulfuric acid is 0.5 thousand liters. That's the only one that has just a single unit. That one's got grams and moles. That one's got grams and moles. So we're going to have to start with the 0.5 thousand liters. Liters of sulfuric acid. I'm just going to use the short SA for that. Now that I've used that, now I have to use something that has liters in it. There's only one unit for sulfuric acid as liters. It's the moles per liter here. So I'm going to multiply that by 3.0 moles of sulfuric acid per 1 liter of sulfuric acid. Okay, remember that liter's in the bottom there. So it has to stay 1 liter. You can't have a 3.0 liters in your question. That 3.0 is not attached to liters. It's attached to moles, and it moves with moles if moles moves up or down. Just a reminder. There we go. Let's cancel those guys out. Now we've got moles of sulfuric acid. Well, I guess I can just go straight to the molar ratio now. So I can use my, let's see, what are we going to put? We're going to put 1 mole of sulfuric acid, and we're going to put 2 moles of sodium hydroxide on the top. All right, that's just again from the molar ratio 2 to 1 there, and then when we cancel those out, you'll see that we are complete that part of our calculation, because I was looking for moles of sodium hydroxide. I've got moles of sodium hydroxide, so we're all good. All right, so let's put our numbers into the equation here. So 0.5 thousand times 3.0 times 2. Well, that's pretty straightforward, isn't it? All right, because that's just 0.5 thousand times 3, which is 1.5, and then times 2 is 3.0. And this is my needed amount. So if you look at now we can compare our two numbers. How many moles of sodium hydroxide do I have? 0.912. How many moles of sodium hydroxide do I need to fully react the sulfuric acid? 3.0. So that means I don't have enough sodium hydroxide to fully react the acid. So therefore, sodium hydroxide is my limiting reagent, which probably isn't too surprising just because we're talking about concentrated sulfuric acid. So yeah, 36.5 grams is like a chocolate bar size of concentrated sodium hydroxide being added in, but concentrated sulfuric acid is very corrosive and extremely acidic, and it takes quite a bit to fully neutralize it. So that amount of sodium hydroxide, not enough. Which means when we are trying to calculate how many grams of water we have, which was the whole purpose of the question to begin with, we are going to start with the sodium hydroxide amount. Because we know that there's only 0.912 moles of sodium hydroxide to react, and we know that's the limiting reagent, we can actually start with that as our first value. And this actually saves us some time, because we don't have to basically redo a calculation that we've already done. All right, looks good. Then we're going to multiply that by, now that we have moles, best thing to use is the molar ratio to switch to moles of the other substance. So I know that I have 2 moles of sodium hydroxide up here. And I've got 2 moles of water over there. Okay, that cancels the moles of sodium hydroxide out, which is good. I got moles of water, I want grams of water. So 18.0153 grams of water per 1 mole of water. Okay, that'll cancel the moles out there. As you can see, this last calculation, by kind of skipping the recalculation step, we save quite a bit of time and headache by basically missing a couple steps. We're basically cutting a couple steps out of the equation, which, I mean, in a unit elimination question, by the time you're doing the last calculation, you've done enough calculating. Make it easy on yourself and use the already half done number to complete your question. Just don't use this because that will give you an inflated value. Okay, so that's 0.912. See, make sure you guys can see that. So 0.912 times 2 divided by 2, just like the last one. You'll notice that that operation is essentially useless because it's going to just return the same number. And then we'll multiply that by 18.0153. So it's really just that times that. And there it is. 16.4 grams of water is produced from 36.5 grams of sodium hydroxide. All right. So that's the end of this week on limiting reagents. There is a quiz this week. It will be one single limiting reagent question. So it's not going to be very long. You guys have done a great job on quizzes so far, so I want to kind of give you a bit of a break. And we will be moving into a new topic next week as we look into solutions, or basically when you dissolve something into something else.